Welcome to Portfolio Stories, Science and Success, a podcast where we explore inspiring journeys, groundbreaking research, and the people shaping the future of science.
Our last guest for this special edition of the Portfolio podcast is Dr. Simona Lodato, Associate Professor at Humanitas University and Head of the Neurodevelopmental Biology at Humanitas Research Hospital. Her research explores how the brain builds its intrinsic networks during development, focusing on the interactions between excitatory and inhibitory neurons in functional cortical circuits, and also how these processes relate to neurodevelopmental disorders such as epilepsy and autism. Simona is also deeply involved in international collaborations and initiatives shaping the future of neuroscience. Thank you very much for being here today with us. I'm thrilled to have you here.
Thank you so much for inviting. The pleasure is mine.
So I would like to start by asking you about your research journey and how it shaped your approach to neurodevelopmental research.
So that's a very interesting question. I think it starts with a failure. I'm the daughter of a doctor, a medical doctor, and from my youth, I thought I was going to be a doctor. Then, despite all the predictions, I actually failed the test by descent to access study, and I ended up in biology, thinking it was my second best choice. But I actually fell in love with it so deeply that I never wanted to try again to go to medicine. And now thinking back, I think I would not have been a very good doctor. I'm very driven by what's behind the disease, what's the mechanism behind it. Not that I don't care about the patients, don't take me wrong, but I think I would have been very motivated to be on the side of the research, and that I think that was how my path started, and it ended up really well tailored for me because I did my master, my thesis in biology, and then I had the opportunity to start some very interesting experimental science, non-neuroscience at the time, but working with astronauts and studied in the European Space Agency how radiation can cause genetic mutations and how this can change. And then eventually I fell in love with neurobiology and the brain and the complexity of the brain, as complex as the star. That's the kind of comparison that I align in my mind. And I started my PhD in developmental neuroscience in the States, in Boston, and where I continue for a postdoc. And then here I am.
I can actually relate very much to your story because my family also wanted me to study medicine, and I felt like by doing research, I may have the chance or may not, but if it happens, I may have the chance to reach much more people. And I had a very bad memory. It was really hard for me to memorize the names of the bones and so on. So I figured it just won't be for me.
Yeah, but now I'm teaching to medical students, right? I'm a professor in a medical university, so I can see the other side. And I can see those that are inspired by the way I teach, which is much more closer to the research approach than just the clinical side, of course. And I can see that there is a different way of looking at things. The lucky aspect is that we need all these figures, right? For science, we need everybody. It's important that everybody finds his own place. So I'm extremely happy. That's why sometimes I bring it up, especially when I talk to young students. Also to think that when you picture someone being successful, being having achieved certain things, that doesn't mean that they were not failures in his path. And I think that for me, what seemed to be a failure when I was 18 was actually the opening of a totally different life that I would not have had if that had not happened to me. And I'm extremely thankful for that failure.
Things really happened the way that they also was. So
yeah.
So your most recent work links immunodeficiency to the neurodevelopmental deficits. So how is that the immune system modulates brain development?
It's a very interesting question. It's actually something we recently approached it. And I think the immune system has probably the strongest impact on the human brain compared to other species. So there must be a very strong interaction between these two complex systems of our body. And they actually share a lot of analogies, biologically speaking, complex, diverse, there to respond to the world, right? So I think it's very fascinating. And we have evidence that a lot of what happens in our prenatal life in terms of immune exposure can be having consequence also long term. But in this particular study, we actually try to show the opposite. We try to show that even in diseases that are historically known and clinically treated as immunodeficiency, there might be evidence, there might be the case that the disease, the same mutation, can affect brain development, priming the brain to even more severe consequences when the immune system gets to be challenged. So I think we would like to expose the idea that a certain disease that have to be looked more systemically, and rather than I will undermine the neurological phenotype of these very difficult diseases where patients are sick and they often get, for the immunodeficiency, they get isolated, the kids get to be homeschooled, so they are deprived by very important social environment for our brain to thrive. Then there might be something that is much more profound in the neurodevelopment itself that is connected to the disease. So it's more an idea it's a sort of a wish that we can look at our patients. I mean, they can look at the patients in a much more, and we can investigate exactly in the interaction.
So looking forward, how do you see the research on brain development contributing to diagnostics and to treatments of these neurodevelopmental disorders?
Yeah, that's a very interesting one. I think it's, I tell my students all the time, it's a very exciting moment to be neuroscientists in general, but also to try to address the question of the development of the brain. We have tools and models and approaches that just 20 years ago when I was studying were absolutely even impossible to imagine. We have a way to look like opening a window into the human brain development and explore mechanisms that would have been completely unforeseen before. So I think the different methodology, the advancement, the technological advancement, and the curiosity that keeps driving this question will definitely contribute to a better understanding of what we're talking about. I think in some cases, we're redefining some condition. We don't want to talk about ASD in the same term as we used to. We try to differentiate and, sort of stratify diseases that very often would accumulate. And we're looking at neurodegeneration now with a neurodevelopmental angle. So we're trying to understand how much development can even impact things that don't go wrong until people are 40 or 50. I think it's a very, very exciting moment. There'll be definitely discovery in this field.
Thank you. I very much look forward to following your research in the coming years. I would also want to ask you a few personal questions as a researcher. So, for example, what challenges have you faced balancing major career milestones with your personal life? I read in your CV that you had a period of maternity leave during your early career.
Yeah, I'm the mother of two sons, and they were both born when I was doing, at the end of my PhD, the first one, and when I was doing in the middle of my postdoc, the second one. And I was in the States when this happened, so it may not be the easiest country in which maternity can be, perceived. But so let me state, I don't think, I don't personally experience any trouble, any trauma, any difficulty. I was extremely lucky. I'm married to a scientist, which helps, in sharing the path. But I think there is a lot of work to do for family in science, much more than just for women in science. And there is clearly still a different way women experience the job world in general. And I don't think science is excluded. I only hope that providing models for younger trainees and show them, I can't tell that was not difficult. Has always been difficult, but I don't regret anything. It's really the question how much you like it, and how much support you manage to have around you. I think that's the important thing. I think it's something that everyone, women or men, should always ask for. Your network, your support, your safety environment is very important. That's what I'm trying to establish in the lab. So I hope successfully. But I think even if we don't personally experience these kind of difficulties, we have to be open to the fact that they might be there, and to support other women, other colleagues, and generate, platforms where everyone can be heard or speak, and also try to create a culture that is the most inclusive possible. Because, I do study diversity in the brain. I don't think that a very limited pool of scientists will produce more or advance more than a rather diverse pool of scientists. I think that the diversity really matters.
It makes total sense. I completely relate with you on that. So I know that you are also the happy recipient of an ERC Starting Grant. How difficult was it to get it, and what did you find crucial in preparing a successful application?
So it's a one lifetime experience writing an ERC grant, at least for me it was. I applied only once, which was my last shot. And I have to say it was in the middle of COVID. I was writing in 2021, and I had my kids all over the place. So they were homeschooled in that moment. So I remember funny moments on the writing, but I also remember an amazing time to think and explore and dream about what I wanted to do. I think it's been extremely instrumental in shaping what I really wanted to address. And it even just writing it, I think, is a great opportunity. Being awarded is, of course, a privilege. And I'm sure there are many excellent proposals that don't get funded for, any random reason. But that doesn't define the excellence of the science. Other people, I think it's just a very fortunate opportunity, especially in countries where there is no much fundings on the national level, where you cannot rely on, deadlines that are always happening. For my lab, it's been a game changer completely. We can do the experiment, we could dream big, and, I feel like I'll inspiring other generations much better. And unfortunately, you need money to do the kind of science we do. So,
yeah, I think that's the reality. So, speaking of the next generations, what advice would you offer to young researchers, and especially women looking to pursue neuroscience and establish their own research group?
It's hard to give advice that can fit all. I think usually when I often get to be, pull out for questions and contact by people that I don't even know. And I try to be always available, because I do remember it was, the day before yesterday I was there. So it's really close memory to me. I think everyone should be aware of the challenges that this job poses you to. But also you learn to fall down and stand up again. I think it's a sort of a cycle, and the earlier you know that you're not alone, it's not talking about you, it's not talking about your science, it's a learning curve. And the earlier you establish a network of people that you can rely on, and you can expose your ideas, you can, for the ERC, for example, for me it was really strategical, have friends and colleagues from other field listen to my talk. I encourage them to get exposed. I would encourage them to not get shy. We always have been there. There is no stupid question. There is no silly argument that you can have in this case. I think we all have gone through this. And, sometimes I think I should to write a not to-do list as a young BI, because I think I made so many mistakes at the beginning that, now I can probably advise on what not to do, which is, I think, equally important to understand. So don't get discouraged. It's difficult for everybody. And I think it's the transition itself that is very difficult. You might be a successful postdoc, you feel very efficient in what you do, and you jump into a role. People trust you. You can do something that you have never done in your life. Management, bureaucracy, managing people, managing money, it's challenging. While the only thing you like to do is continue to do science. So I think it's a very harsh transition. but surrounding by trust mentors, find mentors, even if they are not really there for you, find them, and use any generosity that people can have with you. I think it's important.
Thank you very much. So this has been a truly engaging conversation. Thank you very much for sharing your science as well as your personal experience with us. And we wish you all the best and all the success. And we look forward to seeing how your lab and your research moves forward. So this episode marks the end of our first season of Portfolio. Thank you for being with us in this first of its kind bottom-up initiative with Łukasiewicz Port, and we look forward to seeing you in our next season. In the meantime, stay curious, stay inspired, and keep exploring the wonders of science.
Thank you for watching, and see you in the next episodes.